Let's solve this problem together. We have a 5 times 10 raised to power negative 3 kilogram of liquid, which is at its boiling point and is being evaporated in 20 seconds through the heat generated by a resistor of 2 ohms when a current of 10 ampere is supplied. So we are to find the specific latent heat of vaporization of the liquid. So what happened is that there is a change in state because the liquid had already reached its boiling point. And then when you continue to supply it when a liquid has already reached its boiling point, so what happens is that the liquid begins to change state from the liquid state to the gaseous state. So, and the kind of heat that is involved in the change of state without necessarily changing the temperature is known as latent heat. So we want to find the specific latent heat of vaporization. And then the expression for this latent heat, Q, which is the quantity of heat, is given as ml. So where Q is the latent heat of vaporization, m is the mass of the thing that is being vaporized, while L is the specific latent heat of vaporization. This Q is the heat of vaporization. L is the specific latent heat of vaporization. Now, moving forward, we have where is this source of heat coming from? This is a case of transfer of heat. The heat is coming from the resistor, which current is applied, and all of that. So one thing we know is that the quantity of energy that is coming from the electrical supply. So electrical energy is given by I squared RT. That is if we are dealing with current and resistance. So if this is current and voltage, that would have been I VT and so on. So in this place, I'm going to be using I square VT. So let's do the calculation. Now, the Q that is coming from the resistor and through the current that is being supplied to it, that will definitely be 10 ampere, which is 10 squared multiplied by 2, then multiplied by the amount of time that it ran, which is 20 seconds. So we have 10 squared times 2 times 20. If you do that very well, you should get 4,000 joules. 4,000 joules. So that implies that 4,000 of joules is the quantity of heat that is being used to vaporize this guy. So this Q and this Q, they will be the same because this is the source. This is the source of the energy, and this is where the energy is being transferred to. So this Q, which is 4,000 joules, will now be equal to the product of the mass, which is 5 times 10 to the negative 3, and the specific latent heat. And what are we solving for? We are solving for the specific latent heat, which is 4,000 divided by 5 times 10 to the negative 3. So if we do this very well, we have 4,000 divided by that. So we have 4 divided by 5. That is, so approximately we'll have 8 times 10 to the power of 5 joules per kilogram, and that would be the specific latent heat of vaporization. If you want to see more calculations like this, don't forget to like, subscribe, comment, and follow. If you also have any question that you would like me to address, then you can comment and I will see what I can do about it.